All right, we're broadcasting. So, okay. Well, I think with using the software, I think I understood it pretty well. Did you guys have any questions about the homework or anything, or the individual?
No.
Prep? Okay.
For me, it's just saying, I just have to keep doing things over and over and over again.
Yeah.
And I get it.
Yeah,
It's just,
likewise.
Yeah. Exactly. Okay. Well, then I guess we'll just go right to the quiz and start it and get going on it.
sounds good.
Lesson 11 group meeting.
Yes. Lesson 11 group meetings start. Okay. All right. It says in previous lessons we have assumed that the population standard deviation sigma was known. In this lesson we are making a different assumption about sigma. What has changed? We assume sigma is unknown, right?
Yes.
Okay. The null hypothesis is HO8, and the alternative hypothesis is that it's greater than 8, and the population standard deviation sigma is not known. Becca collects a sample of size n equals 9 and computes x equals 11 and s equals 6. Use this information for questions 4 through 5. Is sigma known? No.
This is a trick question somehow.
Yeah, I know. I'm like, it just says right up there.
It says it right in there. It is not known. So I guess they're just making sure we're reading.
Yeah.
If we do the formulas, we're not solving for standard deviation, so it's
No. No. I mean, if it's the sample, which is S, then we know that, but we do not know. So it says, what is the value of t round to 1 decimal point? So this is where we have to take the formula. So t equals, and then the mean is what, 8? Minus, okay, there's the population, let's see.
So the mean is 8, so it's 8, oh wait.
X is 11, so, okay, so it's 11 minus 8, sorry. 11 minus 8
divided
by the S, which is 6, divided by the sample, which is 9. I'm going to open up my sheet. Okay.
And I'm getting like a 0.1666. Am I doing something right?
I got something different. Let me double check.
Yeah, I'm still working on it because I'm doing it in Excel, so it takes me a little bit longer because I'm going to make sure all my parentheses are in there.
Yeah.
Okay.
Yeah, I'm getting something different.
Okay, I probably did it wrong, so hang on.
I'm getting...
Okay, I get 1.5.
That's what I got.
Okay.
Oh, I know what I did. I know what I did. Hang on. $1.5, you said?
Yes, is that what you got?
Yeah, I didn't do the, I didn't divide 6 by the square root of 9. I just timed them together for some reason.
Okay. So 1.5, okay. And it's just to the 1 decimal point, so we're good. Okay.
Yeah.
So use the following values, which are pulled from the data file body temp, copy and paste them into your software you are assigned to use, which I have open. Okay. Let me go ahead and just get that copied and pasted in. I don't know if that's going to work, though. Let's see.
I'm going to try and do the same thing. We're doing inference, right? Quantitative inference.
Yeah, it's the quantitative inference thingy. Okay. I'm just going to put all these scores in by hand.
Come put it on my feet.
1, 2, 3. So there should be 20 entries, right?
I think so. Okay, I'm just going to sort them really quick. I've got 24 entries. Am I too many?
Well, it starts at 4, so you're right. It's right. Or it starts at they put that column. They didn't start until the 4th or actually the 5th.
Okay.
So yeah.
So it is 24. Okay. All right. So I have. So what are we looking for? Okay. It says what is.
Well, first you have to put in. You have to make sure you change your null hypothesis.
Okay.
And make sure you change your.
Sounds good.
Test and your level of significance.
Okay, so it's trying to find the significance of 95, is that right?
No, well, that's what so the level of significance, did we put that in the confidence level? I know I'm getting things a little confused.
Yeah, the confidence level is the level of significance, and so I think 0.05 is the 95. Because if you add 0.05 to 95, it'd be 100, right?
Yeah.
Okay. I think that's what that one is. I think 0.01 is for 99, and I think, I don't know, the other one is 90 is 0.10. Okay, so it's 95, which I have in there, and then the null hypothesis is that it's equal to 98.6.
Well, so for the significance level, oh, right. Okay, I'm following you now.
And then it's less than, so.
0.05, but okay, I'm following.
Okay. And then we're trying to find,
So we want the X bar.
Which is the mean, right?
No, that's X bar is the population samples. So yeah, that would be the mean.
So I have 98.220. Do you guys have the same?
Yeah.
What are you looking at? Which one do you want? The X bar.
I think it's the mean.
That's what it is.
No, the S is the standard deviation. Oh, it might be this. The only two numbers that we've ever grabbed out of this graph are either on that variable 1. Oh, how many samples do we have? Do we need to change that? It doesn't tell us. We need to change that to 0.
I don't have anything in it.
Oh, it automatically calculates 20. Forget it.
But yeah, in the first part of the homework or the individual preparation assignment, it asks for like the statistics, and the X bar, which is what they're asking for, is equal to the mean of this program. So at least it was with the homework assignments.
Yeah.
So I think it's the 98.220. I'm not sure what else it could be.
I'm just double checking one more example.
Sure.
Yeah, okay, we're right. So the mean is the X bar. I need to write that down somewhere so I don't forget it.
Mm-hmm.
So okay. So the S then
Rounded to 3 decimal places. I have okay, what is that? I have this other thing, and I think it's the I'm not sure if it's the standard deviation or standard error of the mean. I think it's the standard deviation.
That's what I'm looking at. Well, I have that chart too from the last lesson.
Okay.
Looking at an example, let me just see what he pulled. So S.
I could try to input the numbers I had before and see which one it was that they had grabbed for that answer in number 7.
These numbers are so small, it's hard to see. Hold on. All right, I'm just going to look at the notes.
Oh, okay. I'm going to look back too. I know I took pretty good notes, but my brain is all mush now.
I know. Okay, so S is the standard deviation.
Okay.
So that would be 0.922.
Yeah, 0.922. That sounds right to me.
Okay, so the t-score, now we just have to solve.
Well, we can just take it right from that graph, or we can calculate it, but
Is that the 68.987?
No, it'd be -1.
Negative 1.843.
How did you get your answer? Are you working it out by hand, Phil?
No, I'm just looking at this t-sample t-test for mean thing, the quantitative inference procedures, and there was just a t thing on there, so I just thought that was what a t-score was. But
it does. So we're got to figure out why yours is different. Did you change the null? You know, when you pull up the program, did you change the null and the well, we didn't have to change the confidence, I don't think.
no, all I did was put the numbers in on the left side.
Okay, so you have to go up under the null hypothesis, because our problem states a different null than what automatically pulls up as the sample.
Mm-hmm.
Okay.
So you want to change that to 98.6.
And then the confidence level is 0.95, which I think that is automatic. and then the type of test is less than.
The confidence level is what?
It's 0.95.
Okay, that's the same. What else did I have to change?
The null hypothesis is 98.6.
Where's that?
Okay, so if you're looking at the program one sample t-test for means, there's summary statistics, and then there's a box right below that.
I have two sample t-tests. Why do I have a 2 sample t-test?
Okay, go to the very bottom of that thing, and there's 1 sample t-test, paired sample t-test, 2 sample t-test, and over there's different tags at the bottom of your spreadsheet. So I think you need to go to the 1 sample t-test.
Okay. Do I have to erase the 5, 6, 7, 8, 9, and 10 numbers, like the 5, 10, 15, 20, 15, 20, that are already there to begin with, like the first?
Yes. Before you add your numbers, yes.
Yeah.
Yeah, okay. Thank you. Sorry, I don't know.
You can just highlight it and clear content. That will make it go quicker.
Okay. What is the null hypothesis?
It is, sorry, let me go back to it. Okay, the null hypothesis is 98.6, and the type of test is less than.
Okay,
You just
there we
click
go.
the down arrow. Okay, and the confidence level is 0.95. And so your T is down there, like in the 1 sample t-test, it
Yep.
says negative 1.843.
Okay.
And then it has the DF or the, that big long one.
P-value.
Yeah, exactly.
Okay. So our p-value is just 0.04.
0.040, yeah, because I guess we have to round it or to the 3.
Oh, yeah. There you go.
And then number 10, it says what is the correct decision based on this evidence, and I would say it's less than the alpha, the 0.05, so we would reject the null hypothesis. Is that what you think, Gina?
Yeah, because it's lower than our level of significance.
Okay. I just want to make sure I don't know, my brain's screwy this morning, so I'm like, I don't trust it. Okay. It says use the following values, blah, 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 these values. Okay. So we just need to enter in all these numbers now to that software.
I love it when they give us these numbers instead of having to pull up another program. To pull up
Yes. Yeah.
There should be 25, right?
Hold on, I'm still doing it. I got.
Yes. And then I'm going to sort them just to make sure. I don't know if that matters at all in these, but
I always do too, just to make sure.
yeah, because sometimes it changes the numbers. So. Okay.
Oh yeah, we changed the need.
Okay. So we are trying to find the null is 40. And we're trying to find if the type of test is that if it's different or not equal to.
Wait, I accidentally clicked on. What are we supposed to have?
Let's see. What does it say? It doesn't really say. Oh, it's a level of significance of 0.01, which would be 99.
Okay.
It says that in the, yeah.
Okay. So then in my confidence level, I actually put 0.99.
Yeah. Because it's, let me make sure that's right, because it says 0.01, right? So if it was 0.10, it would be the 90. If it was 0.05, it would be the 95, but it's 0.01, so that's 99.
Okay. And then we're doing not equal to.
Yes.
Right?
Yes.
Okay.
What is the p-value is what it's asking.
Should be 0.995.
Yeah, that's what I've got.
Let me make sure. I've got it shrinked here. Yeah, I've got 0.995.
Yeah. So we would reject the null for sure on that, or
fail to reject, yeah, because it's higher than the 0.01. Okay, you decide to try another alternative hypothesis. This time you use it's less than 40, so we got to change that. Less than.
So our p-value went down.
Yes, it did. Are they asking for p-value? Let me go back.
Yeah.
What are they asking?
P-value increase or decrease?
Oh, okay. It decreased. What decision do you make?
We still fail to reject because it's still bigger than our
It's
level.
0.4. Yeah, it's 0.40. Yeah, so it'd be the fail to reject.
What do you mean it's 0.40? You mean 5?
Oh, I'm sorry. Yeah, no, I'm just I don't know. Yeah.
Just making sure I'm following.
I've got 0.502, so it's still more than the 0.01, so we would fail to reject. All right, and then compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one is wider? Oh, well, I didn't write those numbers down, so we'll have to change that back.
It doesn't matter, because remember that how they were saying that when the as the confidence level goes up, the confidence interval gets bigger, and so the whole center.
Yes. Yeah. So it went up, so it increased. Is that what they want us to say? Is it increased?
Well, no. So they're saying which is.
Oh, which one is wider? Oh, it would have been the second one. Oh no, I'm sorry, I can't hear you. The 13.
No, I'm thinking it's 11, right?
Well, which one was the confidence interval bigger? It was 95, and then we went into 99, right?
You have just a second.
Yeah. I'm gonna just compare them really quick, just to make sure. So, with 99, we have 17.474 and 62.621. If I go back to the confidence level of 0.95, and it was, what did we have, not equal to? So I have that confidence level as 23.499 and 56.597. So let's take a look here.
Where's
The bigger, the wider span, the larger one was the first one, 11. Yeah, because it goes from 17 to 62 in 11 and 23 to 56 in 13.
I thought the only thing that we were changing is the type of test.
We are, but because our p-value for 11 is higher, which means kind of the same thing, right? When you have a bigger p-value, you're going to have a bigger spread.
Mm-hmm.
And since our smaller p-value, because our p-value is the what is the exact words for our p-value?
Margin of error? Is that what you're talking about, or
is that what it is? I need to look at my definitions here. But the way I was thinking at it too is if we were to put, you know, in your notes where you write that as the confidence level increases, the width of the confidence interval also increases. You know, that spread gets bigger.
Mm-hmm. Mm-hmm.
The same, it holds true with as the p-value increases, a bigger width, a bigger confidence interval width.
Mm-hmm.
I'm not saying very well, but from what I understand, it would be question 11 is the bigger, or the
yeah, well, I mean, if I just compare the two confidence intervals, the number 11 is definitely bigger.
Right.
I mean, there's a bigger spread. It goes from 17 to 62 in 11, and the confidence interval for 13 is 23 to 56 point something. So
another way to just sort of, I guess, or to put to solidify it in your mind, if we were just to go into that p-value as it stands right now, and right now it's 0.502, let's change it to like 0.802, and you'll see how it changes. Wait a minute. Did it change? I messed that up.
Because on my t-test for mean sample thingy, all I'm doing is switching the type of test, and my confidence intervals stay the exact same.
well, I mean, the 11 was confidence level was 90.95, and in 13 the confidence level was 0.99. So you have to do that, and then the first in number 11 it was not equal to, and then in number 13 the type of test it was less than. So
I thought it says that the only thing you're supposed to change is the type of test, because in 11 it says use your level of significance as 0.01, but in 13 it just says this time just change it to less than 40 and keep the same level of significance.
Yeah, you're right. Okay, let's think about this then again. So if we have a 0.99, I'm working through all of the whole problem again. So we have 0.99, and we have on 11, we have a not equal to.
yeah.
Our p-value is 0.995. Confidence interval 17.4, 62.621, and then in problem 13, our confidence level is the same. So we're just changing
It doesn't change.
p-value changes 0, 2, 3, and our intervals stay exactly the same. So then the answer then is that they're the same, right?
Yeah,
Yeah.
I think they stay the same. Good catch, Phil.
Yeah,
You're
that
right. It doesn't say, it says in question 13 to keep the level of significance the same.
so the only thing that really does change is the p-value.
Yeah.
Yes.
And the p-value is what is the definition for a p-value again?
Let's see. Trying to find my definitions here.
Okay.
Oh, and you've already had one of these. Oh my goodness. Okay. That.
It's from the last unit, but I can't. I just want to.
Yeah, I'm trying to look at the old. I know it's in the last chapter. Let me see. Or is it in the last unit? I can't remember. Isn't it just like the population parameter? Let's see. No, I don't.
Let me look it up and just Google it. Okay, so the p-value is. I know there was a better definition than that. Hold on. Well, all I'm getting is that it's the test static, so it's or statistic, which is probably it's the probability if the test statistic really were distributed as it would be under the null hypothesis. So, well, anyway, I think I feel better about that answer, that it's the same, because
Yeah.
as we literally punched it in, the confidence interval value changed, but
Okay. So it stays the same for 15. Okay. All right. Is there any other ones that we wanted to go back to? I'm going to just go back and make sure I've got everything filled in.
We got 100.
Oh, did you submit it? Okay.
Yeah, I got scared. I had to submit.
I'm always scared. It is crazy. Okay.
Good. That's good.
Yep.
All right.
Got that about the interval thing.
You got the what?
I'm glad Phil caught that about the
I
interval.
know, me too, because I was like, oh, it changes, but no, it didn't change until after that
So
question.
I was assuming it changed too. That as the p-value and as everything. Anyway. So, lesson learned. Confidence interval does not change with p-value. All right.
All
Well,
right.
thank you guys.
Thank you. We'll see you guys next week.
Yeah.
Yeah.
So next week, our for our group assignment, the first due right next week. Oh wait, is it next week or the week after that?
I don't know.
I think it. Okay, on here it's saying it's not due until week 8, which is like 3 down from here.
Okay.
Well, maybe if you guys get a chance in the for the next lesson, if you want to just look over what's all of the project divisions are and everything, then we
Okay.
can start talking about what. It shouldn't take us very long after we all have a chance to look at it. Then we can make
Okay.
and decide what we want to do our study on.
Okay.
Do you guys want to like swap phone numbers so that we can communicate outside of the
Out of
hangout?
here?
Yeah.
Sure.
Sure.
Hey, that way, in case one of us can't show up or we needed extra help or something.
Yeah.
Oh, yeah, that's a good idea. Okay. Okay, I'm ready. Anybody want to get theirs? Go
My
ahead.
phone number is area code 307
Uh-huh.
248
Okay.
3556.
Okay. Mine, if you guys are ready, is 469-767-4827.
Okay.
Okay, mine's area code 719-237-5052.
Great. You guys both accept text, right?
Yes.
Okay. So do I. All right. Yeah. So we can just shoot each other a text if we have a question or need something. So
Okay.
that's great.
All right.
Thanks, guys.
Okay.
Yeah.
Bye-bye.
Bye-bye. Bye, guys.